Hello students, this is Mr. Bornheimer, and today we're going to be talking about scientific notation. I know, it's super exciting. Okay, here we go. Okay, scientific notation is a way in which scientists express really large numbers and very small numbers in a way that is easy for them to understand. Okay, we do understand really big numbers, really small numbers. But the problem is sometimes those numbers are so big or so small that it's not easy for scientists to use them. And because some scientists use these numbers a lot, it's a way that we came up with this thing called scientific notation that helps us to better understand these numbers and to better use them in our calculations. Okay, so let's go ahead and take a look here. Okay, scientific notation. What is scientific notation? It helps us as scientists, and let me go ahead and make sure I'm writing this correctly. It helps us as scientists write very large and very small numbers in a format that is useful to us. Okay? Let's go ahead and take a look at the basics. Here's an example of scientific notation. 4.37 times 10 squared centimeters. Okay? Now, what we need to understand is that this is actually one number. Okay, it's one number. The format in which we have written it has some basic parts though. Okay, so let me kind of outline those for you. The first part you should notice is the placement of the decimal point. Okay, the decimal point here is always going to come after the first digit. Always. And you have to understand that that first digit will never be 0. Right? So in this particular case, the first digit is 4, and the decimal, as we should predict, will come right after it where that red arrow is pointing. Now, there may or may not be anything after that decimal. Okay, give you an example of what this would look like if there was nothing after the decimal. It might look like this. 4 times 10 squared. The decimal's really there, even though it's not physically there. But it still is there. Okay, this would be very similar to 4.0 times 10 squared. They have almost exactly the same value, but yet they're still 4 being multiplied by 10 squared. And we can see that. So what you should note here is that when we're working with scientific notation, we will almost always be working with numbers that have a digit that is not 0, followed by a decimal point. Then there's going to be a 10 in there. Okay, there's always going to be the times 10 raised to a power. That is the key part of scientific notation. And that is the part that oftentimes confuses people as to when you have a decimal, how do you write it in scientific notation? Or if you have something in scientific notation, how do I write it as a decimal? And so that's the part that I want to focus in on today. To do this, we have to understand powers and exponents a little bit better. Let's take a look at just to kind of refresh our memory on exponents. Let's come up with what these numbers represent. Okay, what we're going to be doing is we're trying to work from numbers that are easy, like positive exponents, to negative exponents. And what does that mean? Okay, so the first thing you should understand is by looking at these, what do these represent? Well, 10 squared is really 10 times 10. And as most of you know, and you can guess, it is right on. It's 100. Very good. Oh man, I knew you guys could get it. Then there's this next one, and it is 10 raised to the first power, which is really just 10 times, well, it's 10, you know? And then remember, the exponent is a multiplier. It tells us how many times we're multiplying that number. Well, in this case, it's one time, or really it's just 10. Now, 10 to the 0 power. This is a tricky one. I'm going to write this in a different color. Anything raised to the 0 power. Anything. 7 raised to the 0 power. 6 raised to the 0 power. 5 raised to the 0 power. 1 million raised to the 0 power is always going to yield an answer of 1. Always. Anything to the 0 power is always 1. Okay. Now on to the next part. 10 to the negative 1. Well, this is where it gets a little tricky, okay? And I'm going to kind of work that example right here inside the blue box. 10 to the negative 1 is really the same thing as 1 over 10 to the first. Okay, that's what you should understand. Anytime you have a negative exponent, it's really representing some number, as a fraction. Okay, so in this particular case, it's 1 over 10 to the first. And we know that 10 to the first, as outlined here, is just 10. So this is really going to be just 1 over 10. And if we write that as a decimal, 0.1. Okay? Now, I want you to focus in on where this is headed. Take a look. 10 squared, 100. 10 to the first, 10. 10 to the 0, 1. 10 to the negative 1, 0.1. Let's take a look at that progression for a minute. Okay? 100, 10, 1, 0.1. Let's put a decimal in every one of these numbers where it would be if it was actually there. It would really be right here, right here, right here, and right here. Now, notice that the decimal keeps moving, in essence, over a little bit. Okay? Take 100 for an example. If 100 is really, if I were to kind of go over to 0.1, it's just moving it over. So really, if I'm looking at this, 100, to get it back to 1 is, well, I moved it 2 places. If I move the decimal 2 places, that gives me 1.00. Okay? If I move it 1 place, that gives me 1.0. If I have it here and I don't move it, it's just 1. And if I move it the other direction here, it gives me 1. Notice that all of these numbers are 1. The way that scientific notation works is it's all about moving the decimal so that we can take a number that's in decimal format and somehow pull out something times 10 that we can multiply it by. I know that seems kind of confusing, and this is a tough concept, okay? So let's just keep going forward here. Let's take a look at these two examples, 10 to the negative 2 and 10 to the negative 3, okay? Let's figure out what these would look like if they were decimals. Well, remember, when we have a negative exponent, we're really writing something as a fraction. So 10 to the negative 2 is really the same thing as 1 over 10 to the positive 2, which is really the same thing as 1 over, and 10 squared is 100. And if you convert that into a decimal, it's really the same thing as 0.01. Okay? 10 to the negative third. That's really the same thing as 1 over 10 to the third. Notice I'm taking it and I'm moving it into the denominator. That's really the same thing as 1 over 10 times 10 times 10. Well, 10 times 10 is 100. That's 2 tens. Times 10 is 1,000. So this is really 1 over 1,000. If we write that as a decimal, that's 0.001. Notice where the 1 ends up. Here it ends up in the hundredths. hundredths place. And here it ends up in the thousandths place. How interesting. Hundredths place and thousandths place. So really what we have going on here is we are learning how to convert numbers that are in exponent notation, like these, and we're learning to convert them into basically decimal notation, like these. Okay? All right, let's figure out how to use this in practicality. Here is an example of a number in scientific notation, and you will be asked in your homework to convert numbers that are in scientific notation from scientific notation back to a decimal. You will also be asked to do that in reverse, which we'll look at in just a minute. Okay? So the first thing I would do is I would treat it just like a multiplication problem. Okay? Break it down into two parts. This is really important. Two parts. Okay? So the first part is going to be 4.34. So we're just basically copying this right down. The second part is taking what we have here, copying it down here into decimal notation. Okay? Well, 10 to the negative 1 is the same thing as 1 over 10 to the first, which is the same thing as 1 over 10, which is the same thing, okay, make this very clear, as 0.1. So really what's happening is we're taking 4.34 and we're multiplying it by 0.1. Okay, so I'm going to go ahead and bring down the multiplication symbol. I'm going to put my 0.1 in there, and now I have a math problem here that I can work with. That's the same thing as 4.34 times 0.1, and this is something we do all the time in mathematics. Okay? The answer to this would be what? Anyone want to take a guess? Do it right now, real quick. I will time you. It will take just a brief second. Go. Fantastic, fantastic. Boy, I knew you guys could do it. All right, when you multiply by a decimal, your number gets smaller, okay? Think about that. When you multiply by a decimal, okay, like this, which is really a fraction, you're taking a fraction of it, which is something smaller, right? If I only take a fraction of the pie, I only want a piece of it. It's smaller. Okay, well, decimals are like fractions. They just look different. So in this particular case, I'm taking a fraction of 4.34, okay? And this actually ends up equaling 0.434. That is the answer. That is the exact same thing as 4.34 times 10 to the negative 1. It's just not in scientific notation anymore. Okay, let's take a look at another example of this, except now let's work it back the other way. Big, long number, okay? This is an example of a number that would be very inconvenient for scientists if they had to write 0.000000563. Well, that's really inconvenient, okay? But if they can write it quickly in scientific notation, it's going to be a lot easier for them. All right, so the first thing we have to understand is how many places are we going to have to move that decimal so that it's past the first non-zero digit. Really, we're looking to move that decimal to right here. Okay? We're going to move that decimal to right there. All right, so let's count it. Okay? 1, 2, 3, 4, 5, 6. I'm going to have to move that decimal 6 places. I'm going to write that down over here in the side. Okay? I like to call it the loop-de-loop-de-loop-de-loop-de-loop method. Okay? Because I'm looping that decimal over. So, in this particular case, I had to move that decimal 6 times so that I could end up with something decimal like this. But you see, 5.63 is not the same number as 0.0000563. It's much larger. I'm not looking to change the number. I'm just looking to change the way it looks. Okay, we've talked about this before. So one of the things that I want to do is I want to then compensate for the fact that I moved the decimal by adding times 10. But the question becomes, what is the exponent? Well, here's the deal. If your number started as a very small number, okay? If your number started as a very small number, the odds are that your exponent, okay, the number that goes on top of that 10 is going to have a negative in front of it, okay? This right here implies a negative exponent. And the number that goes up there is the number of places you moved the decimal. So I went loop, de-loop, 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 de-loop. I went 6 places. And those 6 places, that's going to be my exponent. So because my number started out very small, and I moved the decimal 6 places, I'm going to put a negative 6 up here. And that's my answer in scientific notation. That number in the box is exactly the same as the number up top as a decimal. It just looks different, and now it's in scientific notation. Okay, let's work through another example here. Let's say now that I have 40,400. Okay, and not really sure why the number is a different color, but we don't need to worry about it. Okay, 40,400. You know what? Better erase it and make it the same color, just in case here. Here we go. That's what I'm working with. 40,000 is a big number. And as scientists, we might find it very useful to write this number in scientific notation. Okay, so the first thing I'm going to do is I'm going to write this number with a decimal in it. I think that'll be much easier. So when you have a number that's much larger than 1, write it with a decimal. So the first thing I'm going to do is I'm going to say, okay, well, this is the same thing as 40,000. I'm going to leave the comma out so I don't get confused. 123.0. Okay, well, that decimal right there is in the right spot. It just doesn't show up in the top part because it might not actually be necessary to write it. But I write it because it helps me. So here we go. I'm going to take this decimal and I'm going to move it now over so that it's just to the right of that first non-zero digit. In this case, the 4. I want that decimal right here. Okay, so it's going to become 4.0. And to get to that 4, I had to move the decimal 1, 2, 3, 4 places. Okay, 4 places. Write that down. 4 places. All right, so now I've got 4 point, because I moved that decimal to right there. Okay, 4.0. But that's not the same number as 40,000. I need a multiplier. I need something that I can add to this to make it so that they are the same value. Remember, scientific notation. We are not looking to change the value of the number, just the way it looks, so that it's easy for scientists to use. Okay, so here we go. I'm going to add my times 10, and the question now becomes, what is the exponent? Well, when your number starts out being very large, that usually means that you end up with a positive exponent. Okay, so my positive exponent in this particular case is going to be a positive however many places I move that decimal. So in this case, a positive 4. That is my answer. That is the number that is equal to 40,000, but it's now written in scientific notation. Okay, let's do 2 more examples, and then we'll call this good. If you have any further questions, obviously you can always contact me at bclassroom.com. Here we go. Next example. Let's go 36, 300 and, let's see here. Let's go, oops, my computer screen is kind of being weird here. Boom, there we go. Let's go 360,704. Okay? Let's convert this into scientific notation. Well, really, the decimal is right here at the end of the number. And I need to move it so that's all the way at the other end, just to the right of that first non-zero digit, right there. Okay? Your scientific notation always starts with a number, decimal, then followed by however many numbers you need. So in this particular case, this would be, I want 3.60704. The decimal is now here. But remember, 3.60704 is not the same as 360,704. They're the same value. So I have to add in the times 10, okay, in order for it to make sense. So I add in the times 10. Now my number started much larger than 0. So that means it's going to have a positive exponent. And I have to look and I say, okay, how many places did I move it? Well, I moved it 1, 2, 3, 4, 5. So there we go. There's my answer in scientific notation. All right, last one. Let's start with a decimal again. Okay, 0.00000000000746. I got to write this in scientific notation. Well, the first thing I have to understand is where's that decimal going to go? Okay. Well, I have all zeros until I get to here. I have to go one place past, put the decimal there. So I'm really looking for a 7.46 times 10. Now I have to figure out what that exponent is. All right, well, let's count it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. All right, so now my number started out much, much smaller than 0, which means that my exponent is going to have to be negative. So this is a negative 12 places past the decimal. All right? That's how scientific notation works. I'm sure you're all going to do a great job with it. If you have any further questions, please let me know. Otherwise, I will see you in class. Talk to you later.